Just 1 second. I'm just setting up the screen. Hope you guys are doing well. There we go. All the pictures on my second screen. All right, we are being recorded. And that's Stefan, Gauli, Sebastian, Dane, Isaac, Ray. Who else is there? Evelyn, Helena, Alana, Feng, Christian, Jasmine, Amelia. I'm not Amelia. That's Amelia. Saeed, Carla with a K, Jasmine, Varun, Roxana, Adil, Katie, and that's Julia. How are you guys doing? It's a nice afternoon. I don't know how the outside has been. Like some clouds, some sky. Looks very pretty. Looks nice. We're going to talk more alcohol chemistry. My plan is to switch to ethers, talk about ethers just a little bit, do a little bit of naming of ether, and then what else? Then talk about cyclic ether, that's called epoxide, and then wrap it up, okay? That's the plan. All right, let's go to the board. I think it's 3:31, already past a minute. So let's go to the board. The board looks good, except for that I haven't cleaned it yet. All right, let's clean my board. Let's clean the board. And start talking about chemistry we have learned. Alcohol chemistry is a little involved because it, basically it covers SN2, SN1. Before you get there, you talk about like preparing the alcohol. Like alcohol is great to have on the shelf in your lab, but then you need to really like prepare it, like prefabricate some body parts before it's ready for the reaction. So it's not that simple. It's not as simple as using an alkyl halide, what you have done in 128A. You are essentially using something like an alkyl halide in many cases, but either you are making a specific alkyl halide from the alcohol, or you are making a sulfonate ester from the alcohol, then you are subjecting it to the next reaction. Those reactions are very similar. And I know that it can be boring because you have seen it already probably in 2 classes. I'm going to do it one more time and that will be it. I'll draw all the nucleophiles on the right side so that when we use them, you guys know, like you have the entire collage or the spectrum of nucleophiles right in front of your eyes. I need to clean my glasses. Pretty dirty. 1 second. Sorry about that. There you go. All right. So we are. So M128V, and today is March 16. And this is up to which the camera focuses. We're still talking about alcohols. And then let's write down the nucleophiles. I'm going to go fast, okay, because you have already been exposed to it twice. So nucleophiles, list of nucleophiles, H2O, NaOH, ROH, Na plus, O minus R, better version of it, NH3, Usually you don't need to pull out the proton, but if you want, you can do it. You might check your previous knowledge by asking yourself how many lone pairs should that nitrogen have? 0, 1, 2, 3, 4. Think about that. You can have primary amines as nucleophiles. You can have secondary amines as nucleophiles. Not tertiary. Tertiary amines don't work as nucleophiles, but they work as base. We will discuss it maybe at some point. Then we can have H minus as a nucleophile, hydride, but hydride doesn't come as hydride, they come in two packages. One package is sodium borohydride, another package is lithium aluminum hydride. They're both reducing agents. They provide that. Carbon nucleophiles, you can have R, MgX, where R is an alkyl group or an aromatic group, which we can talk about later. And these are called Grignard reagents. We have discussed it. I'm not going to write it down. And then you can also have R, a triple bond, a minus charge, so an alkynyl anion and a corresponding cation. For example, sodium plus. So this is also a carbon nucleophile. Oxygen nucleophiles, okay, nitrogen nucleophiles, hydrogen nucleophile, and carbon nucleophile. Okay, so this is the list of nucleophiles. All right, that's it. So now we start with an alcohol. Let's say RCH2OH, that's a primary alcohol representation. And how do we use this molecule to do an SN1 or SN2 reaction? Well, you can't just use it. So you can use something like HCl and it becomes Cl, or you can use HBr, then it becomes Br, or you can use thionyl chloride with heat, more trustworthy reaction, okay, then it becomes Cl, or you can use one of those guys, R prime SO2Cl with a base, and it becomes R oxygen SO2 R prime. Okay, so these are all set up to do the next reaction because now you have a good living group. So let's use all these 4 different compounds. Let's just showcase a bunch of different use different nucleophiles and see what happens. If you take that guy, I'm going to do that reaction using a different color. How about red? So if we take that and use one of the nucleophiles, I don't know. How about an amine and a primary amine? How about, that's a sketchy reaction. I'm not going to talk about it right now. I don't want to do it today and get distracted. Let's use a secondary amine. Primary amine will become problematic. We will discuss it later. Not today. I want to cover some material today. So let's use a secondary amine. Okay, and the secondary amine will be, so essentially for the secondary amine, there will be one NH and it's attached to something. So what do you want me to do? How about this amine? And we don't really have to now name the amines, until we get to that point. Maybe we'll never get to that point, but maybe we'll get to that point. If you're just curious, we can call it diethylamine. Diethylamine. And the product will be, it's going to be a reaction that you have seen before, SN2. Alkyl halide reacting with a nucleophile. It's going to be an SN2 or 1, 2, because if I ask you, state the nature of the substitution reaction that this reaction is going to be. You should say SN2, not SN1. And if I say justify, what should you say? Well, not that it's concerted. It's concerted because of a specific reason. It's SN2 because of a specific reason. SN2 means bimolecular. Bimolecular means they will react at the same time. That means this is not going to produce a carbocation. That means if it produces a carbocation, it's going to be a sucky carbocation. It's going to be a primary carbocation. So you should say, because it's a primary alkyl halide, it will undergo SN2. If I say more, that's not enough. Then you should say, well, it has to go SN2 because SN1 won't work because it's going to produce, it has to produce a pretty bad, unstable carbocation, primary carbocation. Go back and read those chapters or refer to those notes, your previous instructor's notes. If you need help, as I said, I can help you during office hours, not now. Okay, so it's going to be one-step reaction. Okay, I'm just going to show you this reaction just to remind you that you need to produce the final product as a neutral product. I will not give you full points if you put that salt in a salt. So as this happens, what does the product look like? Chlorine is out, and this is in, and it has a hydrogen, and it has two ethyl groups. Do you see how it happens? Let me pause for 15 seconds and make sure you understand what happened now, and why there is a positive charge. If you're completely lost at this point, you don't know what happened, then you should be really worried. If you know what happened, but you don't understand why there is a positive charge, you should still be worried about yourself. You should probably study harder to get through the semester or to pass or get your desired earned grade. Okay. If you are completely clueless how it happened, then I can't help at this point. If you know what's going on, but then you're worried, like, why there is a positive charge and what does it look like? Well, this is what it looks like. Nucleophile attacks the alpha carbon, kicks out the leaving group is out, and the nucleophile is in. Nucleophile is in, but this is not it. This is not what goes as the final product. Okay, mind you. So what happens, and you might be very tempted to use the chloride minus to pull out the proton, and that's probably what's going to pull out the proton. I'm not going to argue with you, but in my class, in order to earn full credit and in order to earn my faith in you as an organic chemist so that you can earn more bonus points down the road, okay, I want you to use an uppercase B and pull that proton using that and not using this, even though it could be that. I don't want you to do that because I can guarantee there will be other species in that reaction that will also be pulling that proton out. Okay, it's going to pull the proton, it's going to leave that bond here, and it's going to be an equilibrium arrow because we are losing a proton to a base. Whenever we lose a proton or add a proton, we use equilibrium arrows. That's what you need to get used to. What does the product look like now? Well, it looks like this. R lone pair is back, and boron that the base has picked up a proton. So this is the final deal, final product. Okay. If you might have wondered, like, why doesn't Shantanu or Dr. Maitra put the tertiary amine in here? Well, tertiary amine doesn't have a proton, doesn't have a hydrogen to lose at the end of the reaction. So it will always stay protonated. You can never make it neutral. So that's why tertiary amines don't work. Let's try one. So that's the reaction. Let's try a tertiary amine here. Let's try trimethylamine. Okay, that's a methyl group, that's a methyl group, that's a methyl group. Okay, trimethylamine. Let's see what happens. Okay, SN2, because this is also primary. So it's SN2 reaction. And what does it look like after the first reaction? Well, how do you make that nitrogen neutral? You can't. That's it. This is it. So it's going to be a salt for as long as this molecule is alive. And because it's a salt, the bond between positive charge and negative charge is ionic. Because it's ionic, it's going to be water soluble, very polar. Because it's water soluble, you can wash it off. Okay, everything else is going to remain in your organic solvent. This guy is going to be water soluble, so you can wash it off. You can give it a water wash, and this molecule is going to be out. So tertiary amines are used as sponge for protons. There is actually a compound called proton sponge. I don't want to talk about it right now. When we talk about aromatic compounds, we can discuss it. So tertiary amines don't work. No good. No good as nucleophile. This is not what you want. You want a neutral organic compound at the end of the day. There is no way you can make a neutral organic compound, because if there was a hydrogen, then you could pull it off. You could pluck the proton and make the nitrogen neutral. But this is it. This is it. No use. Okay, I'm not going to use that molecule. So you get the point. It's like, why no tertiary amine? The answer is here. Why no tertiary amine as a nucleophile? All right. So let's use this guy and do like a couple of reactions. Okay. So let's use this guy to how about reacting it with sodium borohydride? If you see this, what should the product look like? If this sulfonate ester, this is called a sulfonate ester. What should the product look like? What do you guys think? So
the entire,
yeah, so let's help me stepwise so that everybody can see what's going on. So when we use sodium borohydride, what's the actual nucleophile in there? You don't have to use any funny business with sodium borohydride. I don't expect you to do that. I don't expect you to draw the sodium plus and BH4 minus and then use a hydride from there. Or you can cheat. You can just, and that's totally fine with me. What is, when you see this reagent, which nucleophile are you going to use for the mechanism, for figuring out the product? What's that thing? Look on the right. What is that called? It's an H word. I taught you that name. I want you to pick up. Sorry?
hydronium.
No, this is hydronium.
Hydride?
That's hydronium. That's not it. Sorry, somebody else tried to say something.
Hydride?
How do you spell it, Carla?
Hydride.
Hydride, hydride. Perfect. So we use a hydride. What does it look like? Hydrogen with nothing? No electrons? Hydrogen with 1 electron or hydrogen with 2 electrons?
2.
And what would that make its charge? Neutral, plus or minus?
Minus.
Neutral.
Yeah.
Oh, minus.
Everybody with us, everyone is following so far? Yeah. So it's going to be, what reaction will this be? Sulfonate ester plus H minus. What is it? How do you determine what kind of reaction will this be? Elimination, substitution, addition, hallucination, mesmerization,
Substitution.
substitution. SN1 or SN2? What kind of alpha carbon is this? Where the living group is? This is the living group. This whole darn thing is the living group. That's the living group. And that's your alpha carbon. How many hydrogens are there on an alpha carbon? How many alpha hydrogens are there? 2. If you have CH2, is it a primary, secondary, or tertiary? You don't know, you don't want to answer, you're lazy, you're sleeping. What's the right answer? Unmotivated? Somebody else who hasn't spoken today. When you have CH2 living group, what kind of alkyl group is this? Is it primary, secondary, or tertiary?
Primary.
Primary, secondary, or tertiary? Sorry?
Primary.
Primary, thank you. Primary alkyl with a living group, do you think they'll undergo SN1 or SN2?
SN2.
Somebody else who hasn't spoken today. Why SN2? Why primaries cannot do SN1? Give me a one-liner answer. Why all of these molecules cannot do SN1? We already spoke about it. Somebody answer who hasn't spoken today.
The carbocation is unstable.
There you go. That's that simple. Carbocation is not stable. So the hydride, how will this reaction happen? What will the hydride do? That's just a nucleophile. When you look at the hydride, don't feel intimidated. Think nucleophile. So the lone pair is going to attack something. Where will it attack? Where will that arrow end? Somebody else who hasn't spoken today. Nucleophile attacks which carbon in SN1, SN2? Come on,
The
guys.
alpha carbon.
Sorry?
Alpha carbon.
Yes. And as you push the alpha carbon, somebody has to give from the other end. What's that? If you want to really earn your respect and maybe 2 extra bonus points, I want you to show that mechanism this way. The nucleophile attacks the alpha carbon. This bond breaks into oxygen sulfur bond. Another bond opens up. If you do it slightly differently, if you do it this way, yeah, sure, I will give you full points. That's fine. That's fine too. But if you do it the other way, this way, and if you haven't screwed up anything on that page, I might add 2 more points. You know, I do that sometimes. Some of you know. Okay, so the green is better, purple is okay, no problem. It's okay. So what does the molecule look like? That's it.
Wait, just going back to the previous one, the sulfonate ester. Sorry, does that purple arrow represent the transfer of an electron pair? Because it kind of looks like it's transferring like a radical. I don't think it is though.
Here,
Yeah, that one.
the purple arrow indicates 1 way you guys might do your mechanism in the exam. And that's not really wrong, but I prefer that you guys do it the green way. So are you concerned that if there is a Are you concerned that this is a radical? Are you concerned
Yeah,
about this arrow?
it just looks like a half arrow, that's all. So that's what I was
Half
wondering.
arrow? No, it's just illusion.
Okay, no problem. Yeah, thank you.
So you get an alkyl molecule. If you reduce it, you can actually reduce it. It's sometimes it's done this way. Sodium borohydride doesn't really do a good job. Usually lithium borohydride does a better job. But at this point for this course, either of them is fine. I'll give you full points. Okay, you guys haven't been exposed to like a plethora of reducing agents. Okay, and then the side product will be R prime SO2 O minus. And it's a great living group because the O minus is not, the negative charge is not localized. It can float around between the three oxygens. That's why it's a good living group. Okay, so that's one example. I'm not going to slow down a lot with this chemistry. So the bottom line is, what can you see? What can you expect from this chapter in the next quiz or in the next exam? Well, something like this. I might say it reacts with HBr. Put like a little box. You have to show the product here. Okay. I might show you on the arrow titanyl chloride and heat, and empty box. And then from arrow, another nucleophile. I just choose a nucleophile from here, and then I say what's the product and some related questions. Okay, so let me snap a picture. I'm blocking the camera. Sorry about that. Okay. I'm going to erase the board. I don't think I'm going to slow down because we have been talking about it for quite some time. So let me just show you a star reaction. Star reaction, basically, I'm pretty sure you have seen it before. So essentially, different chemistry going off from the center. So let's use a sulfonate ester because that's something that you haven't seen before, or maybe a titanyl chloride. I don't know. We'll see what's going on here. You know what? Let me just erase everything. You guys have been exposed to the nucleophiles, and I think you must have been exposed to the nucleophiles while you were learning SN1, SN2. Next quiz will be closed books, closed notes, open Zoom so that I can see everybody. If you don't do that, then there will be a penalty. If you can keep your cameras off, but you will be graded out of -5 points or -10 points. I haven't decided yet. So that's the deal. And then if I change my mind, I'll change my mind later on. Okay, so let's do like a little like a little wheel reaction. Okay, you can see something like this. So let's start with an alcohol. Let's use a real alcohol. Okay. First question, maybe Hold on just a second. Let's say this is molecule 1, this is molecule 2, this is molecule 3, this is molecule 4. This is molecule 5. Molecule 6. Molecule 7. About and some solvent. I'm just skipping all of that. Okay, and I will be asking you. So, question 1. Let's say question 1A. Name 1. Question 1B. Fill in the empty boxes with appropriate structures. And how many of them are there? 8 minus 1, 7, 7 times 3. So let's say there is the points for naming the molecule is 3 and 21 points for that. And then I ask you, show the mechanism going for reaction going from, I'm just going to shorthand it for 1 to 2. That's a 6 points. So this could be a quiz, like 1-page quiz. Yeah. All right, help me. Okay. Name the molecule. How would you name it?
Two.
Figure it out on
3.
your own. Yeah, figure it on your own. Write it down somewhere. Then dictate. Anybody who's
3.
ready? Go ahead.
3-methyl 2-butanol.
3-methyl 2-butanol. I want 2 of you to comment, somebody other than the answer and the person who is given the answer, if this is correct or wrong. 3-methyl 2-butanol. Does it ring a bell? Does it sound good? Don't give me your thumbs up. Just speak up, please. I'm not looking at the screen.
It sounds good to me.
Sounds good to you, Carla? Upside down puppy. That's how you look like. Anybody else? One more person?
I might have said 2,3-dimethyl 1-butanol, but maybe I'm looking at the wrong chain.
What did you say?
2,3-dimethyl, 1-butanol.
Are you thinking about that as a group and that as a group?
Yes.
If you're doing that, then the main chain is not that long. Main chain is not butanol, then the main chain is 1, 2, 3 propanol.
I see. Okay, I got it now.
Got it? So don't do that in the exam. It's good. I like your courage. You're not afraid to be wrong. That's actually a very important human attribute. Okay, knowing that we might make mistake, we might fall on our face. It might sound like an old man giving you a philosophical lecture, but it's very important. If you don't know how to suck up your error or mistake and say sorry, I do stereotype, okay, and I am biased and I am prejudiced, and I probably have some ego too. I mean, pride and prejudice, they go hand in hand. Nobody's perfect. And I've seen people in certain parts of the world who are extremely reluctant to accept that they have made a mistake and say a genuine sorry. Sometimes you're forced to say sorry. So I think that's very important that you are ready to make a mistake in public and say, I'm sorry. So that's very, very important. Thank you. Thank you for doing that. Somebody else might be benefiting from it by learning what not to do. Okay, let's go one at a time. What does this molecule 2 look like? Can somebody help me write it? This guy. What does it look like? Anybody?
Where the OH would be, it would be the SOCl2.
It would just be a CL.
That's okay. That's okay.
Never mind.
Hold on. Carla, you wanna step back and you think? Okay, you said, what did you say?
I said it would be like the whole molecule. Yeah.
Okay, I'm not mocking you. I'm not making fun of you. It just looks kind of funny. Okay. That's not it. You need to you guys need to study. That looks pretty ridiculous, by the way. Don't do that. If you do that, then you lost all my respect for you as an organic student. And even if the next page is speak and span, I'll probably take some points off. I'll look for opportunities. I'm just kidding. I'm not mean. Okay, that's not the right answer. Carla, you want to correct yourself?
Yeah, I think what I did was like I tried to do like the in-between step.
That's not what goes in the final box. Final box
Right.
is the final product, final car.
Right.
Not without the seat, without the steering. You know, Honda will not ask you to bring your own steering to drive your car home. So final product, what does the final product look like?
It's just the Cl,
What is that Cl called?
the chlorine. Yeah, sorry.
That's okay, don't be sorry. Again, you are doing favor to others. Okay, that's what happens. I might ask you, just name it. Okay, if I ask you to name it, how would you name it? You can go from there. 2-methyl 2-chlorobutane. I'm just messing with you. That's not right.
3-methyl 2-chlorobutane.
You just said what I said, and then I said I'm messing with you. That's not.
3-methyl, not 2-methyl, because you said 2-methyl.
Becoming kind of funny. Okay, you said 3-methyl. You fell in my trap, nevertheless. 2-chlorobutane. Who is this? This is Eshan. Eshan, you just dug a hole and you fell. You made your own trap. 2-methyl 2-chlorobutane. Is this correct or not correct? Shoo or boo? Or cheer or jeer or something? Throw paper.
Is it just 2-chloromethyl 3-methyl butane? Like you switch the chlorine and the butane, or not chlorine. Oh God.
You got it. Yeah, alphabetical order. C comes before N, even I know that. Even though English is not my first language. Yes, it's I'm just gonna switch it. I'm not gonna rewrite it. Don't expect me to do that. Okay. 2-chloro, 3-methylbutane. Okay. All right, so this is wrong. Okay, which one should we do next? Okay, this chloro guy undergoes sodium hydroxide reaction.
So you're gonna have
So,
oh,
so,
never
so,
mind.
so slow down for a second. I have a different question. Is this, what kind of reaction is this going to be? If I say this is going to be SN something, do you think it's going to be SN2 or SN1? Or is it difficult to ascertain that based on what information you have? What's the right answer? Varun, you can answer that question.
Okay.
SN2 or SN1? Why? Why not?
So I'm gonna go with SN1 actually, because of the leaving group.
What
Actually,
kind of
no, no.
alkyl halide is this? Somebody else who hasn't answered today. Is it primary, secondary, or tertiary? If you have trouble determining that, you should be really worried about this course. If you do not know what it is, you're like, oh, primary? I know that in my country, when I went to elementary school, we used to call it primary school. And then I went to secondary school. Then I went to higher secondary school. We don't have any higher order of secondary alcohol. Is this primary, secondary, or tertiary alkyl halide? Which one? And why? Let's get to the bottom of it. I'm not going to leave you alone just because you're not being able to answer. What is it?
It's
Somebody-
secondary.
Sorry?
It's secondary because the carbon is connected to 2 different carbons.
Yeah. Or you could have also said secondary because it's connected to 1 hydrogen. Yeah, that either way, that's fine. Totally fine. Okay. Right answer is the right answer. Good. Thank you. Appreciate it. Okay. So is this reaction, what do you guys think? Is this reaction, so Varun said it's because of the living group, he thinks it's going to be SN1. You said SN1 and it's because of the living group. What does the living group have here to make that determination? Justify your answer, Varun.
So I have to read this again, but I think it's a weaker leaving group than like bromine and iodine.
Okay.
So it's gonna be slower to leave.
If it is a slower living group, what other clues you have? What do secondary alkyl halides do? SN1 or SN2?
SN2.
Who said that? Jane. What do primaries do? What do primary alkyl halides do? SN1 or 2?
SN2.
Primary 2. That's it. Done deal. What about tertiaries? Do they do SN1 or SN2? Somebody else who hasn't answered today. Try tertiary alkyl halides. Do they undergo SN1 or SN2? Somebody who hasn't answered today. I want to give chances to everyone, not just a group of usual suspects. I'm not picking your names yet, but I might do that.
SN1.
Sorry?
SN1.
Tertiary is SN1. Secondaries, it's an opportunist politician. Depending upon the wind blowing and what's going on in Washington, DC, they will probably choose their line of action. Okay. So this guy could be SN1 or 2. We don't know. So I know there is no solvent. So I'm deliberately not giving you hints, dropping hints with the solvent. There is some other hint there. We talked about the first nucleophile we talked about was water, and then on the side I wrote this. They both accomplish the same job. They both provide the reaction with an OH. OH is what ends up staying in the molecule. Okay, one is a so-so nucleophile, one is an awesome nucleophile. So can you draw some conclusion based on the nucleophile that we are using? Is this a pretty darn good nucleophile or a pretty horrible nucleophile? Where is the nucleophile in this reaction? Going that way, going 2 to 3. What's your nucleophile?
The hydroxide.
Sorry, hydroxide, right? So I didn't draw the minus charge. So let me just show you that, and then maybe it can help you a little bit more to kind of go forward. So if you have OH minus, that's a good living group or a bad living group? Somebody who hasn't spoken today. OH minus is a sucky living group or a pretty darn good living group?
It's a sucky one.
Is it really easy to make from OH minus? Bad living group means it's very stable. Is OH minus very stable? Can you just take water and pull the proton and make OH minus? Is it super easy to make OH minus? What's the pK of water? Who remembers from 128A? Anybody remembers the pK of water? And pK of water and pK of, let's say, acetic acid. pK of that and pK of that. Who remembers? You have forgotten? Anybody. You don't have to be the nascent one who hasn't, that's the wrong word. Yeah, you don't have to be someone who hasn't responded yet. Anybody. What's the pK of water?
Isn't it like
15.
14?
Sorry, Eshan, what did you say?
I thought it was like 14, I thought.
No, 14 is off. Anybody else wants to get a little closer to the correct number? Sorry,
15.
15 is wrong. 15.7
7?
7.
15.7 or 15.5, depending upon which textbook you're looking at. So this is 15.5. Anybody knows the range? You can give me a 5-unit range, like 55 to 60, 40 to 45, 30 to 40, around 15, 0 and 10, or 0 and 5, 0 to -5. What's the pK of acetic acid, carboxylic acids?
Gonna be like around 5.
Soroush, you're absolutely correct. It's 4.74. So if I see a carboxylic acid, if I ask you, you give me a range, 0 to 5. Okay. So which one is easier to pull a proton from, water or acetic acid?
Acetic acid, right?
Don't ask, you have to answer. Acetic acid or water, which one is easier to pluck a proton from?
I would say acetic acid.
Acetic acid. So when you lose a proton from this guy and you get that, and when you lose a proton from this guy and you get this, which one is a more stable conjugate base? OH minus or COO minus? Which one is happier? You make a lot of proton here, because it's a strong acid. You make only a little bit of proton here because it's a bad acid. Why is it a bad acid? Because higher pK. This is lower pK. Lower pK, stronger acid. Greater pK, worse acid. Worse acid makes less proton. Strong acid makes more proton. That means, which one is more stable? OH minus, let's call it A, anion 1, and let's call it anion 2. Which anion is more stable? Anion 1 or anion 2? Connect the dots. So you need to be able to connect the dots. I understand pandemic is boring and you guys are frustrated, but if you want to earn your grade in this course, test 1 is not going to be representative of your final grade. I'm going to keep the cameras on and see how it goes, and keep the books off, closed. And I just want to see how the test 2 and the next 2 quizzes go. And based on that, your final grade will be determined. I'm not going to change the grading policy. I just have a feeling that it might change some of your grades, the pattern. Okay. So A1 or A2, which one is more stable?
A2.
A2 is more stable. Excellent. More stable. Less stable. What does mental stability and chances of biting have in common? How do they relate? If I'm more stable, will I be more likely to bite you? Or if I'm more unstable, less stable, I'll be more likely to be more reactive. Which one is more reactive? OH minus, A1 or A2? What does reactivity have to do with stability? Are they directly proportional or are they inversely proportional? One goes up, one goes down. What do you guys think?
They're inversely proportional. So the more reactive, the less stable.
Which one is then more reactive?
A1.
A1. I don't know if it is cutting off from the camera. This is more reactive. So nucleophilicity wise, as long as we are talking about their nucleophilic behavior, nucleophilic strength, OH minus is a better nucleophile, or this whole carboxylate anion is a better nucleophile? A1 is a better nucleophile or A2 is a better nucleophile? The one that's more reactive is a better nucleophile. Just connect the dots that way. Which one is a better nucleophile?
The OH.
Sorry?
The OH.
OH minus. Okay, so that's a better nucleophile. So going back to our original problem, so this is a pretty darn good nucleophile. Now connect the dots between nucleophilicity and the mechanism of SN reaction, SN2 and SN1. If you have a pretty strong nucleophile, imagine that there is a house and you are the child, you're the son or daughter in the house, and your parents are thinking about replacing you with a paying guest. Okay, and they don't know if they're going to kick you out first and have the paying guest come in, or have the paying guest kick you out at the same time, concerted or not. Okay, the house is a secondary house, not primary or tertiary. It's not a clear-cut picture. Okay, you may be kicked out first, and then the paying guest might come in, but the paying guest might come in and kick you out from the front door at the same time, concerted way. Okay, if the paying guest is more aggressive, if the nucleophile is a stronger nucleophile, which mechanism is likely to prevail, SN2 or SN1?
2.
So it's more likely to undergo SN2 reaction just based on the information. Make sense? Everybody, I'll try to keep my mouth shut for like 15 seconds. Just absorb what we have just talked about. 423. I think we still have some time to.
So the reason why it's a SN2 is because of the strong nucleophile.
Strong nucleophile, because you can mess with the nucleophile. Okay, you can mess with the nucleophile. If the nucleophile is really strong, you can actually make it go SN2. I know that the nucleophile strength doesn't matter for SN1, but that's when it's a clear-cut SN1 from the structure of the molecule or the solvent. This one can be either way. It can go SN2 or SN1. When it can undergo SN2, then you can actually use a stronger nucleophile and make the paying guest jump the fence, come in from the back door, and kick out the child and get in there. So it's going to be concerted. So this can affect the nature of the reaction. Next question. If you are going to select a solvent to make it go SN2, what solvent would you use? Give me a name of a solvent. This is again from 128A. Which solvent, give me maybe 1 or 2 or 3 names of solvents that would promote SN2 and not SN1. One person at a time. You guys know, what solvent would you use?
Acetone.
Acetone, Saeed. Yeah, acetone will probably work. Polar aprotic solvent. Sure, acetone. Okay, acetone. Somebody else? Somebody else? Anybody else? Another solvent that's a little more sure shot. Acetone, I'm a little nervous because acetone itself can react sometimes. But I'm going to put it in parentheses. Acetone is a little dangerous solvent to use sometimes. Okay, that's fine. I'm going to give you points. Any other solvent?
DMSO.
DMSO. Somebody else, another solvent.
Acetonitrile.
Acetonitrile. What does acetonitrile look like? Acetonitrile. What does it look like? What is the formula? A big methyl group or a small methyl group? I'm discussing with you. Or a very beautiful methyl group with like 3 petals, 3 hydrogens spinning around. What does
Would like, sorry,
go ahead, Sarush?
would hydrochloric acid work?
Nope.
No. Oh,
Acetonitrile looks like this. Methyl. That's acetonitrile. Okay. Yeah. Another solvent is, anybody remembers 3-letter acronym starting with T? Rings a bell? Did you learn it in 128A? 3-letter acronym, T, another letter. No? Nobody? Are you sure your instructor didn't teach you that? THF. That's also a pretty good solvent. Methylene chloride is also another solvent. CH2Cl2 will work, but THF might work, DMSO might work. Acetone, a little questionable. I'm not going to put that question cross the check mark. Acetonitrile will work. They all have their pluses and minuses. Acetonitrile has pretty high boiling point. DMSO has extremely high boiling point. It's a pain in the neck when it comes to getting rid of it. Another solvent, somebody has missed it. It also starts with D. 3-letter acronym. Who remembers? D something else, not DMSO.
Dimethylformamide.
Dimethylformamide, DMF. DMF. Yes, that's going to be another great solvent for the reaction, but it's a nightmare when it comes to getting rid of it. Okay? Yeah. All right. So with all that discussion, what will the product look like? Will it be same as one of the numbered compounds on the board? Are we going backwards? Are we taking a U-turn, going from 2 to 3? 3 is actually somebody else on the screen, on the board.
It'll look like the first reaction or the first molecule.
Who's this? That's Isaac. Yep, this is actually compound 1. Oops, it's a oops moment. All right, let's do this. Going from 2 to 4, what will the product look like? I don't care at this point, SN1 or SN2, just let's get the product. What will the product look like?
The chlorine would be replaced with the O, and the chain would extend from that.
Okay, and this is Said. Okay, thank you, Said. That's perfect. And there is a very common mistake that happens here. Okay, Now realize that I'm going to draw the first molecule here. 1, 2, 3, 4. Okay, this is going to be the first salt. It's going to be the first charged intermediate. That's not what I want to see in the box. Okay, if you put that, and if there are 4 points or 3 points, I'll definitely take 1 point off. Okay, that's not what I want to do. That does form. When this reaction happens, let me just get this molecule outside here. Okay, so it gets attached and positive charge. I'm going to erase what's inside the box. Okay. From here, so it basically produces that. This is an intermediate. Then the intermediate becomes neutral. How do I make that OH plus neutral? What trick do I play here? I already showed you for nitrogen scenarios. How do I pull it off?
At a base.
Add a base. How do I write the base here in, when I'm rushing through the mechanism? What's my formula for base? What's my acronym for base?
Capital B with a lone pair.
Excellent. And I pluck this, and that bond pair becomes a lone pair. And is that the right arrow? If I'm showing the mechanism here, I'm kind of rushing, Adil. Thank you. What arrow should I use if you're doing this as a part of a mechanism? Like equilibrium arrow, half, or one-headed arrow, or double-headed arrow? Which one is the correct one?
Equilibrium arrow.
Equilibrium arrow, thank you. Okay, and then you get the final product that looks like this strange species. What kind of functional group is that? You may have learned functional group, and we just learned how to make a functional group that's included in the chapter of alcohols. What kind of functional group is that? Do you guys know what that is? It's an E word.
Ether.
Ether. It's an ether. We won't try to name this, but we will try to name something simpler. And we did a lot of review today. Okay. Let's get compound 7 done quickly. What does compound 7 look like? So the main body is there. And then what's out there? What will lithium aluminum hydride replace chlorine with?
Just an H.
Just an H. What about this guy? Again, you're replacing the living group with the nucleophile. What's the nucleophile here? Can somebody tell me the nucleophile is this particular alkyl group? What's the nucleophile? It's a sport, or it's like a hobby. You sometimes throw it and it comes back to you. It has that shape, that alkyl group. What's the alkyl group going to look like when it gets attached to that point?
Like a boomerang?
Boomerang, yeah. So what is the alkyl group called? How many carbons? It's this guy, right?
Isopropyl.
We got a symmetric molecule. It looks pretty cool. You want to name that alkane? I'm not going to do that. All right. Let's finish this board. I mean, I don't know if we can get any further today. 434. Okay. There with, this is a methyl group, CH3SO2Cl and base. What does the product look like here? Help somebody. Let's try someone who has not answered today. Anybody is there that hasn't spoken today but wants to give it a shot? What does the product look like? What next? We are essentially doing review today. Hurry up! I don't have all the time in the world. I'm a busy man. I have to watch the sky and the birds for the rest of the day. I have better things to do. Not that. Okay, anybody, help. What do I put here?
Chlorine.
If you put chlorine, hold
Yeah,
on, just a
yes.
second. One second. If you put chlorine, I have warned you, some of the textbooks do it that way. I don't care what the textbook does. If you react an alcohol with a sulfonyl chloride, I don't want you to put a chlorine there. Okay? Even if the textbook does it, I will give you 0 out of 3. I'm making it clear what you should not do. And this is why you need to at least once watch the video or be in the Zoom class. That's fine. This is a common mistake. It's not thionyl chloride. It's sulfonyl chloride. It adds, okay? Sorry, I was not ignoring you, Dan. But I wanted to make sure that this is clear to everyone that for this reaction, some textbooks do show that the final product is chloro. I don't want you to do that. Okay. If you do that, 0 out of 3, no partial credit. I'm making it very clear. Okay. Anybody wants to help me then?
Yeah, DBM.
What do I draw here? Which element?
Oxygen
Okay, then what?
and S.
Okay, then what? What goes on the sulfur?
2 double bonded oxygens and a chlorine.
Okay, and then what else?
A chlorine.
Yep. What is that functional group called? Who remembers? I might ask you. Name that
Sulfonate
functional
ester.
group. Sorry?
Sulfonate ester.
Sulfonate ester. Yes, thank you. That's a sulfonate ester. So now this sulfonate ester is reacted with a secondary amine. What does this reaction look? What does the final product look like? Help. Anybody? Anybody right now? Open to all. That's the nucleophile. That's the nucleophilic center that's going to attack alpha carbon. We are talking about SN1 and SN2. If you put an eliminated react product, then I'm going to probably take 0.75. Remember, I'll say assume substitution reactions. Unless I specify elimination, don't do elimination. Okay, I'll specify. Okay, assuming it's an SN1 or SN2, what will the product look like?
The end connects. The nitrogen connects.
And then what's on the end?
The two ethyls.
Looks good. I think I'm going to let you guys go right now because no point, introducing a new concept. That's what we're going to be talking about a little bit on Thursday, ether and epoxide. And I'm not going to jinx by saying that this is what we're going to be doing after this. Okay, so hopefully we'll finish quickly and then we can take the next discussion.
Wait, I have a question.
Yeah.
At the first year class, I thought, why isn't there a positive charge on the nitrogen when you drew it right now?
When we move this guy a little bit up, if anybody wants to hang up, that's totally fine with me. I'm not teaching anything new, just teaching something that our question has to do with. Okay, what happens, assuming it's SN2, okay? We don't know, SN1 or SN2. Let's say we are using some appropriate solvent. Let's say it's SN2. Okay, that happens.
Yeah.
What does that, after that happens, what's that intermediate? This is positively charged. So
Oh.
this is the intermediate we're not showing.
Oh, okay. I didn't know that.
Got it?
Yes.
And then comes a base.
Yes. Yes. Yes.
Got it? Then comes a base, plucks the proton, equilibrium arrow, and gets you to the neutral amine.
Okay. Sounds
Got
good.
it?
Yes.
Okay. Good. Thank you. Thank you. And this is Juliana. And I'm going to take a snapshot and call it a day. 5 minutes early. So you can't say that Dr. Mike always stays longer, makes us go. It's so hard on us. He's such a bad person.
I had a question about just on a timeline on when we're going to cover NMR spectroscopy.
Okay. Are you taking the 129B lab now?
I'm not, but I know like I just want to make sure that it's like not on the quiz for
If I don't
next
teach
Tuesday.
anything, it's not going to be on the quiz. If you think that
Okay.
I'm not going to be paying attention to what I have covered, then you have completely judged me totally wrong.
No,
So
I
whatever-
know, but like you could cover on Thursday and then a lot of teachers.
Yeah,
would-
if I cover it on Thursday, then it's fair game. To be
Okay,
honest.
cool.
Yeah. If I cover it, then we'll talk about it. We'll ask. If I don't cover it, it's not going to be in the exam.
Okay, cool.
Anything else?
Have a nice day.
Yeah, you too, Ishan. Bye.
Nice day.
Bye, everybody. Take care. Have a good day.